Hey guys, Chris here again with Project Nerf. I have been playing with the new Elite 2.0 Turbine for the last couple of days, and I tell you, I really like it, but it's time. Let's see if we can crack this bad boy open and make it just a little bit better. Let's do it. Alright guys, so we got the turbine sitting here, and I've already taken the batteries out of it, but we'll go ahead and take the battery door off. I'll tell you, I really like this blaster. It runs on 4C batteries, and there are a few screws in it. Now, if it's like everything else in the 2.0 line, it's going to have clips and solvent welds and all kinds of stuff going on. So who knows what we're going to get into there, but we're going to give this a go. So we'll get these screws backed out. Okay. Yeah, let's see. Okay. We got most of our screws to pop out of there. You go over there. I'm going to put those in this little container here. Okay, so pretty obvious here that the one of the first things that we're going to have to do now that we've removed these screws. I've got one more sitting in here. Oops. See if we can get that thing back down enough to drop the blaster body. There we go. Okay, is pop this black cover here at the hand grip and one here on the main blaster grip. So we should be able to take a small screwdriver with any luck and kind of get underneath that thing and pop it off. We're realistically going to bar it up a little bit. There's one. Okay, I thought I heard a clip pop there. Ow. Stab myself. Oh, dog. There we go, we got that off. Oh, and it just does just clip on. And some more of the tools that we're going to be using. Obviously, we got a little screwdriver here. I have a variety of trim removal tools. These are automotive. I'm a mechanic. I use this kind of stuff all the time. So hopefully these will serve us well in popping the rest of the clips in the body and getting it open. Alright, sorry about the delay there. Went to band-aid up my finger where I stabbed myself. Pay no attention to that. I'm an industrial mechanic, and if I don't get cut or bruised or beat at a day's work, I did something wrong. Let's see if, by any luck, we can get this little trim removal tool underneath this tab here. Looks like it. There we go. Okay, there's one more up front, so I don't want to torque on it too badly, but let's see what we got to do there. There we go. Got that out. All of our little clips are intact, so we're doing good there. So now, we'll take a look here. I did pop one of the clips off the other thing, a little overzealous, but you can see, hopefully, right here at the tip of my screwdriver is a clip, so it obviously pushes in. So we're going to take our screwdriver and push that clip in. Let's see if we can get it to release. Anyway, I'm gonna keep working this. So as you can see, we're most of the way around the shell now. I'm sure I'm gonna have to deal with a couple solvent welds. Let me deal with that. I'll come back and show you where we were, and we'll go from there. Okay, I got it popped open. This clip right here, and you should be able to see on the far side of the shell, right, oops, there, just in front of this screw boss, I did break off. All the rest of them survived intact, which is actually pretty remarkable. Okay, let's take a look inside. What I can see is they continued the theme inside. There were no screws inside this blaster. Now, this is definitely a rapid strike style pusher. Oh, but there's a marked difference here. One, the switch for it is on top, which is great because it gives us plenty of room in this region right here to put a large switch in, because we are going to do a 3-switch setup. All the rest of the stuff, again, just kind of pops in there. Here's our rev trigger. Slides down the lock right here, which has a spring, plastic spring. I don't like those. Let's pop the trigger here. Again, plastic spring, but it's pretty robust. No problems there. This is a lock. This is the Maglock that prevents the blaster from revving with no mag in it. So this is coming out and going to the bin because it's junk. We don't need it. The mag release is a very interesting apparatus here. It's you've got your switch and then a set of 2 cantilevers, and it's a pretty stiff mag lever, so and yeah, pretty easy. Again, no screws. So we want to pop the pusher mech out. Here we go. The board. This switch has a little tape on it, but I'm wondering if it's anything more than that tape holding it in. That ought to be interesting to find out. So we'll peel the tape up. There we go. Let's see if that switch will pop out of it. Yes, it will. No wire cover guide, so that's cool. I can already tell from the front of the blaster that the flywheel cage is actually clipped in. You can see one right here, so we're going to see if we can pry that back and lift the cage a bit. Might need to get our little tool back out and get on the front edge. So what we're going to do is put our little prying tool under there just to apply some pressure. I'm trying to do this without blocking the camera here, guys. I apologize. But yeah, we're going to lift up on the cage right here like that. Actually, that should work okay. And then pop this clip back. Or try to. Yeah, that wasn't a problem. Okay, just need a little different angle here on the flywheel cage. I don't think that's going to be a steep enough one. Okay, you're giving me grief. This front end appears to just friction fit in. I think if we cut it clear, yes, okay, very forcibly, but done nonetheless. I get off our mag release, made a run for it there. I only see, guys, there's 2 clips. There's one back here, and I don't know. Okay, there's 1. There's 3. There's 1. Let's see if we can pop this one and get the cage to start lifting out. Now that front end's out of there. Super tight. I'm wondering if they might have actually put a little solvent weld under the cage, but I don't think so. It appears to be coming, slow but sure. We're free of that clip, so we got 1 more back here, and this was the one I've been messing with for a minute. It's kind of a butt, but there we go. So okay, no solvent weld, 3 clips on the cage. Obviously, there are posts here. But they are not going to work on your standard Strife rapid strike cage. So, we got all that. This switch fits in there. This switch fits in there. Literally, guys, to get the wiring out, you have to clip 2 wires. to get the entire apparatus out of it. So you have to clip the battery leads. And in real life, you could probably just grab a hold of them with your plier. Hopefully I'm showing on camera here. And just pull the metal tabs out. So, come on, don't make a liar out of me. Yes, there we go. Okay, so absolutely no cutting to remove the entire wiring harness, cage and all, complete. So I'm going to take the two little tabs out here for the mag release. Start putting this stuff up over here. Now, our mission here is going to be to swap the motors in this blaster. So we're going to go ahead and cut these wires off of this motor just to get that loose. And we are going to extricate the flywheels. And these ones look like they could be a little bigger pain in the butt than usual, but with a little application of torque here, they seem to be coming off okay. So yeah, this is kind of a big tool to be doing this, but I've mostly got it. A pry in here, a little wedge in there. Whoops, there it goes. Okay, so that's off of there. We got to get the other side. We're going to drop these motors out, wires intact. You shouldn't have to do anything really fancy here. Just there we go. That flywheel popped right off. Well, a lot of room in the cage. So that's exciting. Let me grab my baby hammer and see if they did something foolish like solvent welded the wires in the cage. Hopefully not. They did that on one of them, the Urzo or something. Yeah, buddy. It appears that they actually solvent welded the cans to the motor into the cage. So we're going to have to get a little more dramatic here. And just cut everything loose and gut the motors so we can get in here and grab those cans and rather forcefully, I would think, yank them out. Let me see. There's no screw there. I don't really see anything holding that. A little board on there, but we're just going to go ham on it. One little ground wire right there. There we go. Drive everything out of there. So now all we have to do is extricate the cans, and we'll be ready to put a new set of motors in there. So, cool. I'm going to go ahead and get these knocked out, and we'll continue on. Alright guys, actually told you a lie. The cans were not solvent welded. They're just a super tight friction fit. But once I knocked the shafts through and the caps off, like this one, I was able to just reach in here with a subtle needle nose pliers and give them a little twist and yank, and they came right out. So, no problems there. So we're going to go ahead and put a set of upgrade motors and flywheels in this bad boy. Let's see what we've got in the bucket. For our flywheel motors, guys, what the heck. This thing is cool. Let's do a set of FRVs. So, flipping the cage over. Okay, that is going to be a super, super tight fit, but I think we can press fit it. So, let me grab my little channel lock here and see if we can squeeze that motor down there. Okay, no big deal there. I just took my channel locks and opened up and got a good grip close to center there and just very carefully push those motors in there. Okay, and they still turn. I want a set of wheels. We might can go with Infernos in this thing, which would be awesome. Finders with Infernos equals happy day. Okay, we're going to have to deal with these front kind of dart guides. So I'm going to take my clipper and just cut those out, and I think we're going to have enough room to sneak a set of Inferno wheels in this thing, which is awesome. because they are my favorite. They are my go-to wheels. I really, really like them, and if I can make them fit in a freaking stock cage, that's just exquisite. And it looks like they're going to fit just fine. Look at that. So there's one. All right, nothing else hitting, and what an interesting design choice to use an open cage like this. But our wheels are not rubbing, so awesome. Cage is done. Let's see what we got to do to get into this pusher mechanism. I can see 1, 2, 3 clip tabs. So, okay, I lifted that one with my finger, very easy. Okay, there's 2. Again, this is just with fingers, guys. I'm not even using a tool here. Alright, I give up on that one. We'll put a little screwdriver behind it. And there we go. So that's open. Very, very similar to a rapid strike. So what we're going to have to do is, just like in a rapid strike, if you've never done one, is this region right here, where the end of the motor shaft would come out. We're going to have to cut that out a bit for our new motor. We're going to use an ME2O. Let me grab one. And the reason we have to cut it, it's going to become very apparent. It drops in, but the motor tabs will prevent the motor from dropping all the way down. So we're going to do a little surgery here. We're just going to clip, clip, clip. Just like that. That should give us plenty of room to drop our motor in. Yes. Now we're going to do the same thing on the other side. So, gotta be a little more careful here. I'm actually going to try to cut a little more of this than just do the sides and break it, as is common for me. Because this is actually layered up quite strong. So cut that away. Cut that away. And I think that's going to be in the ballpark, guys. So let's put our worm gear back on this motor. Kind of pay attention to the spacing from the shaft of the motor. You can see there's a little gap in there. We're going to take my little flush cut pliers and see if we can get under there and wedge that worm gear off. Sure we can. Not my first rodeo. And it is just a friction fit. So we're going to push it down on there with any luck here. About the same far, and you can see we're still a little ways out. We got to get that to go in there a little bit farther. So back to our little slip joint pliers here. See if we can make it go. That's pretty close. It might be a hair long, but I don't think it's enough to affect us. As you can see, it's interfacing just fine. As it turns, it's turning a little gear. I think that's going to work just beautifully. So, in theory, so there they are. The motor tabs are sticking through. Everything's clipped back together, so that's upgraded. So let's voltage test everything and double check which direction everything's got to run. And then take a look at the shell and see what other prep work, if any, we've got to do. Okay guys, you can see I put the wires across here and I just left them long. I've hooked up my jumper box. I had a 2S. The battery's a little weak, but that one's working right. Let's take a look at the pusher. Alright, as you can see, we got the cage dropped back down there and clipped in. And that's a really tight fit. I had to go under here and clip out the tabs in the shell. and do a little Dremel work. Because the way the motors are designed, they don't set quite as flush down in there. So we know we got our motor in here. I've got it hooked up to my jumper box. We're going to give it a shake and see if it goes. Looks like it works to me. Oh, yeah, cool. All right, so let me get that unhooked. Get this battery in here. Test box out of the way. Lots of room inside this battery tray. Let's take the pusher out of there. I really am actually liking the whole screwless design more and more as I go along here. Okay, and you can see here we actually did have solvent weld in the blaster. I was kind of telling you guys a lie. Let's see if I can drop the camera low enough where I can get it in focus for you. Right here on this post is a little solvent weld, and right here on this one looked like there might have been a little bit. Oops, let me move that into frame for you. Right here. And the last one looks like I had a little solvent weld there. So there was no solvent weld around the rim of the blaster, but 3 of the posts did in fact have it. So what we're going to do is go ahead and get the rest of the tabs and get this battery tray cleaned out, and I'll get back with you. Alright guys, sorry I didn't bring you with me through the process here. My camera battery died. It's getting kind of old. But you see I cleaned out the battery tray. I just cut out all the little blue tabs that were standing up in here. And now that makes a pretty generous space. This is a 1 amp hour, 1000 milliamp Turnigy graphene 2S, and you see plenty of room in there. You could probably go up to like a 1500. The wiring on this is a 3S Rapid Strike. If you've never done one, I'm sorry I didn't walk you through it. I will post an official wiring diagram that I've been using forever, and I found a great digital copy to print out on MTB's website. It's spot on, and it's very cool. So I'll definitely post that in a still for you guys to review a little bit later. Alright, so we got our motor swapped, our flywheels in, motor switched here. Up at the top here, you can see we put our 3rd switch in. I cut down all the material that was sitting right in here. My finger's at, hopefully you can see it. Just cut that down flush, drove a screw into that boss. Then this boss I cut out of a scrap blaster and literally just hot glued in place when I cut it to length. That holds that switch just fine. This switch, again, I just ridded out a little material right in here. Drove a screw down into my epoxy putty. And I actually used a little super glue right here at the tip of my screwdriver. I don't know if you're going to be able to see it. I'll try to get it up here where you can. Okay, but right here in front of my screwdriver tip, there's a spring, and I hot glued it on. Or super glued it just to the edge of the switch to help act as a return for the trigger. You can see I cut the bottom off, and I cut that goofy plastic spring off of it. So you've got the return spring inside the switch, plus this little bonus one here. Same thing with the rev trigger. But you can see I just wadded out a generous spot down here, put the switch in, and then I super glued one side of this switch to right here. Let me take that out, you'll be able to see it better. So right here, and it sits on the bottom edge, right here where my thumb is at, of the rev switch, and pushes it out quite nicely. So if I can get that back in there, you can hear nice and clicky, nice and clicky. And yeah, so that's it. So let's see. I've taken a look at the inside of the shell here, and up at the top, I cut all of those posts in this area here in the center. I cut all those down because of the big switch that I put up here. I cut out the little guides and supports here and the handle. Alright guys, I got it put together here, and I guess we can give it a test fire. I got a 10 clip with a few in it. We'll see if it's see if we can make it go here. Yep, it works. Boy, that thing seems to be hitting hard. Okay, now, when I went to put it together, over here there was like a full cage that kind of wrapped around the flywheel cage on the inside. Something was catching one of my wheels, and I don't know what. So I've just been kind of methodically removing plastic. You can see I cut part of this boss here off because it was rubbing one. And I'm thinking it might be these guys as well. So what I'm going to do is I'll take my Dremel burr and sand them in just a little bit. And with all the rest of the inside of the thing cut off, we shouldn't have anything obstructing our flywheels. These will still help press down on the cage to hold it in place since it's only clipped. And it should work good. So I'm going to see if I can get it to clip back together, and we'll get it on the range and test it. Alright, we're going to go ahead and try to get some chronos on this. It's a brand new chrono. I've never used this one, and that's a pretty tight gap to shoot through, but we're going to try here. Hopefully you guys can see the readings, but I'll call them out as I get them. So anyway, here we go. 124. Alright, ready to fire test. Just kind of watch that corner. Here we go. 3, 2, 1. And there you have it, guys. A empty 18 mag. That was pretty fast. Alright, guys. How about those results? Shooting in the middle to upper 120s on the stock cage. For a couple of FRVs and Inferno wheels, and then again we put an ME20 in our pusher and got a really, really nice rate of fire out of it. Right, all I've heard on YouTube about this blaster is what you can't do and what you couldn't do, and you would destroy it and this and that. Does it look destroyed? In all fairness, there is some marring on the top of the shell where I popped that last piece of solvent well right in here. So I did mar the shell a little bit, but all in all, the blaster still looks great. It functions flawlessly, and yeah, I really, really like it. My grievances with it now are the exact same as they were in stock form. This mag release is incredibly stiff and kind of hurts your finger to get in there and push it. I use the tip of my finger when I come off the trigger to do that, to drop the mag out. And it would be very difficult given this mechanism to go to a lever style release like we have on the original Rapid Strikes, and the stock is very short on this. Would love to see somebody 3D print something, maybe like a slip-on and something that can kind of clip into it, or maybe through this little gap here, the lanyard mounts. That would be super cool. If you come up with something like that, hey, send it to me. I'll do a full review for you. That would be awesome. But all in all, I love the cosmetic of the blaster. It's one of the few, if not the only, flywheel blaster that is absolutely symmetrical on both sides. They're identical. The clips, I don't find that to be that big of an imposition, actually. I had to pop this thing back open twice after I reassembled it to get everything freed up in there well during kind of my testing procedure, make sure my flywheels were going to turn. And after the initial opening where I had to pop the 3 solvent welds, I got one in here and one on a post there and one down in here, which I pointed out on camera to you. After I popped those initial solvent welds, right now I can open this thing pretty much as fast as I can a stock Rapid Strike. You just get a point, start wedging your way around, and open the clips up. The clips in this particular blaster, because it does in fact have some screws in it. It's got 6. It's got 2 up front, 1 here, 1 right behind the mag well, 1 in the bottom of the handle, and 1 back here behind the battery tray. So even if you break a clip or 2 or 3, it's not that big a deal on the Turbine. I think it's a very moddable blaster. We got very equitable results, and I think it was well worth the time. I'm going to post a link to MTB's Rapid Strike wiring diagram down in the description box below. It's the wiring schematic that I have personally used for years. MTB just happened to have a great visual representation of it. And the only thing that I have to say about that, let me grab a paper copy. Here we go. Here it is. Right down in here, there's some lettering. Hopefully you can see it. This is diodes optional on the one lead coming from the acceleration trigger to the pusher trigger. That is not 100% accurate. if you're wiring your blaster for a 2S, okay, you do not need diodes. It'll run perfectly. It'll return just like it should. However, if you go up on your battery voltage to a 3S, or like the Wraith, my Rapid Strike, to a 4S, you absolutely have to have diodes, because what will happen is the pusher will run away. You'll rev it up, you'll pull the trigger, the pusher will start going, and then all of a sudden you'll let go of the trigger and the pusher will just keep going. You have to have those diodes to stop it from backfeeding. The higher the voltage, the more diodes you need. But where it says diodes optional, that's not correct. It should be diodes required for 3S or higher. But no, I will put a link to this wiring schematic in the description box for you guys. And so that way you can modify your own. Ultimately, I found it a pretty easy blaster to work with. Lots of room up in here to put our third switch in. A little different design than the Rapid Strike, so like your Kelly Industries plate for a Rapid Strike is not going to work for you. You're going to have to manually get in there and mount your switches and things like that, like we did with this one. But plenty of room to do it. Cable management was very easy. And the teardown was super easy. Once we popped those solvent welds on the shell and got it open, you do not have to cut a single wire to completely gut the inside. Not one wire has to be cut. Okay, you yank the battery terminals out and everything else just slides in. The clips on the flywheel cage, don't worry about those either. If they get broken, this side of the shell has female bosses that come down over the post the flywheel cage sits on. So if that post is sitting here, there's a female that comes down over top of it and pushes the cage down. So even if the clips broke, the cage is setting on the 3-post and is compressed to where it's supposed to be by this side of the shell. So it's absolutely nothing to worry about, even if you did break those clips. I think it's great. I hope you guys think it's great. And honestly, I ought to reach out here. I want you guys to remember where you saw it first. All right, this is the first Turbine mod guide on YouTube. Okay, it's the very first one. So I'm asking for a little love. Show me a little love. Tell your friends, tell your family, hey, we got this lunatic over here in Virginia that's getting stuff done for us. Check this guy out. As always, guys, subscribe. If you haven't done it, hit that notification button, because we got some more great content coming up from you. Throw me a comment. Shoot me an email. If you prefer to shoot letters, fan mail address is going to be below. Send me a letter. I'll read it out loud on the air for you. Whatever your preference is, I pride myself on being a little more accessible than some of the other YouTubers. So definitely reach out and contact me. I will be sure to get back to you. Guys, till next time, this is Chris for Project Nerf saying have a blast.